coming. Welcome to the presentation today on simplifying RAG with Databricks Vector Search. So before we dive in, a quick introduction about myself. So like I said, Wilson Mark. I have over 20 years of experience in IT. I started as a software developer for many years, and then moved into the data space in the last close to 10 years now, I think. So I'm currently consulting at SMS Equipment as a data architect and a technical lead for my warranty project there. So previously, I worked at Avalon as a manager of data engineering, a lead data architect at CAE, as well as a lead AI architect at Air Canada. I'm also a Microsoft Data Platform MVP and a Databricks champion. So if you would like to follow me, I can be found at LinkedIn and GitHub at /Wilson-Mark. And I also have a small YouTube channel that I post some of the meetups and videos there at the dash analytics dash lab channel. So feel free to subscribe and connect with me. So let's dive right into the session. So for today, we're going to cover the complexity of the RAG workflow or pipeline that we have in the different technology that we're using. Some of the challenges is how do we integrate the different technology and products together in a scalable and a efficient manner. Then we're going to dive into Databricks Mosaic AI Vector Search to see how Databricks trying to simplify our life by bringing all of the end-to-end products together in order to reduce the complexity of our RAG pipelines. Then we're going to discuss how we can utilize the delta tables and volume to store and manage our data. Since Unity Catalog has been released, that's a key functionality for us to be able to manage our data effectively, especially as we are diving into RAG or any AI use cases that we have. Finally, we'll also do a quick introduction on the Databricks Genie, AI BI Genie there, how you can help us bring quick insights into for our business or data analyst users, and how that directly ties back into the delta table that we will be setting up as part of our materials and demo. So this presentation has two demos. The first demo will be implementing the RAG pipeline or the workflow using Databricks Unity Catalog and Vector Search. We also have a very short and small demo on the Databricks AI BI Genie as well, just an introduction showcase type of demo there. So for the audience, it's important that you have a basic understanding of generative AI, what is a RAG. If you know that is definitely a plus. And if you have any experience in Databricks and some Python experience /SQL would be beneficial as well. So we will do a quick 5 minutes Q&A after our vector search demo, and then we will do a longer Q&A at the end of the presentations here. And all the code that you will be seeing today will be available in my GitHub repository, and the link will be provided at the end of the presentations there. All right, so let's kind of jump in. So for our standard RAG workflow, there is a 4-step process that we usually go through in order to create our AI chatbot. The first portion is data preparations, and what that really breaks down to is we need to extract and ingest our data from our source system, and that's essentially the raw data piece here, right? So this could be PDF files, it could be Markdown, it could be knowledge base API that we want to connect to, or some audio files that you have. So after obtaining those raw data, then we need to extract the relevant data from those specific data sets that we have. Some of them will require us to clean it. Some of them will require additional processing, but some of the key items that we want to extract would be things like the metadata. So titles, descriptions, if you're especially extracting things like from a markdown or from a audio file, right? You want to extract the description of that, and any file names that you might have. Then the next thing you probably will do is extract the contents of the data as well. So for PDF, you want to extract the text out of that. For audio, you want to perhaps obtain the transcription of the audio file. Some of the additional processing you might consider doing if you're working with sensitive data or that have privacy issues is you might need to filter out or remove any personal data out of the data that you're producing. So especially if you're working in the medical field, if there's any patient's name and things like that, you do not want to capture that in your clean data set, if you will. So finally, with all of that data being processed and handled, your next thing we need to worry about is dealing with your embedding model. Each embedding model has a limit on how long that string text can be. So in our case, we might need to chunk our data into breaking up into smaller chunk so that our embedding model can process them and generate factors out of them. So as an example for OpenAI, the text embedding 3 small model only accepts 8,191 tokens. So if you pass in more tokens than that, then you will not be able to parse them and generate an embedding there. So um, so finally, now you have uh, the clean data set that you generated, right? So um, is that this can be kept in memory or this could be written out into a file format like a CSV or Parquet file that you would want to use. Depends on the size of the file. You might elect it to just keep it in memory, but I think it's always a great practice to extract the um, the final clean data set. So if anything happens, you don't have to reprocess that data. So the next step from there is the index and store the relevant data. So we build this clean data set. It's all has all of our fields that we want in our for our chatbot to use. Then what we need to do is uh, pass that each of the roles into the embedding model, the text itself. And the embedding model would tokenize the clean data and store them into our vector database. So in this case, we want to include any relevant data that we want the vector database to use in case if there's any filtering that we need to do in the later on steps. Then the next 2 steps we have are kind of linked together. So that's the information retrieval and the inferencing. So the user will be asking the questions about what is the monthly sales, for example, in our chatbot, and the chatbot will pass these questions into our embedding model, essentially creates tokenize the question that we have, and then we will execute a similarity search. So we'll analyze the data, um, the question that we have, compare with the clean data that we have embedded, and we're trying to find the top results and pass it back to our chat completion model. So in this case, we could be returning the top 5 results, for example, and the chat completion model would uh, compile those 5 specific result and generate a human-like response back to the user. So so that's the end-to-end flow for our basic reg workflow. So for our today's sessions, we will focus on discussing the data preparation to the information retrieval step. Since chatbot and chat completion are complex topics on their own, so we won't be able to cover them in this sessions. But if you guys are interested, please let me know, and we can definitely book a future sessions to cover those specific items there. So now, with the understanding that of what each of the steps we have, the next thing we would like to do is talk about the different tools or framework options we have when we're implementing a RAG solution effectively. So for data processing, there's a lot of options, depends on what you're trying to accomplish. So for example, you can use the Azure Cognitive Search API to extract any form data to text. AI Vision, for example, it's another option where we can extract the PDF text, a PDF out to text, or we can even generate descriptions of an image for our clean data set. For the AI, Azure AI speech to text API, we can also then process any audio and extract the transcription or the text out of the audio file as well. For data processing itself, the actual data crunching or the compute, we can use Spark, which available in Databricks or in Microsoft Fabric. There's other solutions that can be able to process the compute of those data as well. Finally, for orchestrators, we're all quite familiar with Azure Data Factory. LangChain seems to be another popular framework or library that people use as well. For vector database, we have Pinecone, Azure AI Search, or even the Postgres database with the PG Vector library installed there. So a lot of options in vector database as well. Now onto the embedding models, we're going to kind of cover them more quickly, the embedding model and the LLM models there. So OpenAI, Google, and there's a number of open source embedding model available. So for OpenAI, we talked about using the text embedding 3. For Google, there's the embedding Gecko, and then for open source, which is the one that we will look into a little more today, with Databricks is the GTE, the General Text Embedding Model. For LLM, I'm sure everyone's familiar with GPT-4o. We have Gemini for Google, Cloud for Anthropic, and on the open source side, we have Llama 3.3 as well as DeepSeek. I'm sure that has been making a lot of splash on the news around that. So with all of this tool, you often have to figure out how to integrate from one solution to the other, and that could be quite a lengthy process or require a lot of coding to do. So what if you have a way to streamline this process? How would you go about that? Is there a unified platform that can help you simplifying the processing from creating your clean data all the way to your vector database? And this is where the Databricks solution comes in. So for data preparation, as we touched on earlier, we still have to extract our data from source. We can use Databricks for that. And we want to create our clean data set at the end. So in Databricks, all of our tabular data will be stored as a Delta Lake format, which is a table that lives inside Databricks. And for the store index and store relevant data, we would the Databricks Mosaic AI suite provides two main functionality that helps us with the indexing of, and storing of our data. So the first one is the model serving endpoint. So in the model serving endpoint, it hosts the various different model, including embedding and chat completion model for us to use. And if we need to, and it has an out of the box integration with Azure OpenAI as well. So that makes things quite straightforward and simple. And secondly, it has the vector search index capability. So what this does is help us create and store the embedding that we need to create from our clean data set itself. So those two features together um, allows our embedding model to quickly take our clean data set and convert it into the vector data set without the need of bringing in additional um, databases or integrating with different services together. Furthermore, one of the additional benefit of the vector search index is when a new row of data is created in our clean data set, the vector search index would create the new embeddings for us and update the index itself. So you can configure that index to be run on a manual trigger. So whenever you trigger it, you decide to refresh it, or it can be run continuously. So this gives you the control on how often you want your AI chatbot to obtain the latest data for to answering the user's query here. So finally, now we move to the third stage of the information retrieval. So in this particular step, our focus is really executing the similarity search as well as embedding the user's question. So and both of those capability are part of the vector search index solution as well. So yeah, so those are kind of the two main product that two main features that the Mosaic AI suite provides. But let's dive a little more into the how the vector search works. Okay. So for first, in our vector search, as we talked about, we need to create the vector search endpoint on the top, kind of right, the little blue box here. So this endpoint or compute is responsible for managing any of the vector operations that we have. So the next thing we need to create is our delta sync index. And what this index does is it takes our source delta table from the left, and we create the embedding based on the embedding model that we provided. And then the results will be stored in a vector database. Inside Databricks, we'll see that data as an index, as a vector index in our data set. And optionally, we do have the ability to save the embedding in what they call the write back database, write back table, sorry. And this table will contains the embedding from our source in our source data here. So this step number 3 here will be can be saved optionally. So at the end, you will end up with 3 different components or 3 different sets of data in your Databricks. You have your source delta table, you have your index table, which is the data that's been embedded from and exposed from the vector database, and you also can have your own copy of the embedding table and the results coming from the store as a delta table as well. Okay, so the delta sync index is one approach that we could do in using the Mosaic AI vector search. So in this case, the Databricks itself is the one creating and computing all of the um, sorry, computing all the embeddings. So what if you don't want to do that, right? So there's two other approach that you can use with Databricks. So the first alternative is you can provide your source data table with the embedding pre-calculated. So this is also called the Delta Sync Index, but it's with self-managed embedding. It's a configuration you can kind of turn on. And the other alternative is you can directly read and write the factors the factor database and the index, and that's called direct factor access index. And in this approach, you have to manually update the index and by extension the factor database using REST API. There will be no automations like we talked about a little bit earlier, where we can set a schedule in terms of is it a continuous or manual trigger. Everything has to be done through a REST API, so everything has to be coded, implemented by yourself. So for more information, you can check out the Microsoft Learn um, for Azure Databricks for the vector search itself. I'll also paste that link into the chat here for you guys to have a look at that if you guys are interested in having more information around learning the uh, three different types of the vector search. So then let's take one step further to that which is the information retrieval or the step number 3 that we saw earlier. So in this case, the user's questions or the query will need to be passed to the Delta Sync index. This is the approach we're taking. And in this case, uh, the step number 4, which is we would take the inquiry from the user. We have to embed this question to run a similarity search on this question. And this similarity search will give us the top result the that are matching the data that are based on the user's query. And then you will return the best match or the top results that we specify back to the chatbot, which will need chat completion models to generate a human-like response back to the user. Because you'll get 5 individual results, they have to be compiled and summarized. So for the vector search to work effectively, we need a strong data foundations. And in Databricks, we manage that through what they call Unity Catalog. And the Unity Catalog provides a 3-level hierarchy for us to organize our structured and unstructured data. So we'll quickly touch on each one of them. As you know, could be quite a bit of detail here. So for the main takeaway from the Unity catalog, we need to understand is there's a 3-level hierarchy. So starting at the second item is our catalog level. So that's usually could be your business unit that you created your catalog for, or if you're working in a software development environment, you could be a dev, UAT, or prod. That's how you would define your catalog as the first level. So for data team or for the AI team, they might choose to use the dev, UAT, prod nomenclature for their catalog level. For level 2, this is our schema or database. So usually this is project-based or initiative-based. In the data analytics space, often we use the bronze, silver, gold medallion architecture. So depends on the scenario or the areas you're working in. You might see both or one or the other. Then finally, we arrive at the level 3 of our hierarchy, and this is where we want to spend a little bit more time describing. So of course, we touch quite a bit on what is a table, right? So this is a delta table. Things are stored just like your database table that you see every day in other databases. Um, and so that's no difference than what we know today. The next item we want to cover is a volume. So the difference between a volume and a table is that volume is being used to store anything that are not in the delta format. So for example, if you want to analyze any PDF files, you might upload that into the volume or a markdown file, for example. So you might need to do that in order for Databricks to be able to analyze the data to generate your clean data, which then will be in the table or the delta table format there. Okay. So we kind of breeze through a lot of the contents quickly there. But for our first demo, we want to talk about my friend's blog. His name is Connor. He's a good friend of mine. He's also another data architect that um, writes a lot of and publish a lot of interesting articles on Gen AI and securities around Gen AI. So since I found his blog post very interesting, I thought, hey, why don't we create my first demo where we will take his blog, which is in Markdown formats, and let's build a vector solution around his blog. So that way I can easily keep up with what's going on with his blog, as well as extract any insights from it. So, but if you guys are also interested in following his blog, I have the link in the slides here as well. Okay. So with that, we'll flip over to the demo. But just in case if anybody has any questions, feel free to type them out into the chat or and I'll try to answer them along the demo or during the Q&A session. Okay, so this is the Databricks environment that we have. So in here, there's a lot of different tabs and things. So the first thing that we want to look at is the setup script that I have. So what this does is we're going to just quickly hit the run all button so everything can be running while I'm talking with you guys. So the first step here is we want to create our schema of the database we want to create the catalog that we talked about initially if it doesn't exist. This is the top level container that we use. This is before the 3-level namespace that we have. And what this really allows us to do is enable us to start creating our database or the schema and other components so we can build out the proper 3-level architecture or 3-level structure there. I think actually the catalog is the first level. Sorry, I misspoke about that. So in this case, we want to create the BU ops catalog, and in here we will be creating a schema which is called project block insight. That's the schema name that I want to create, and this is all done in SQL. You can also do this in Python as well. I find that for simple commands like this, I like to do them in SQL as it saves me some time for complex query to be used in Python. So as you can see here, the next thing we are doing is creating a volume after we have the schema created. So if you can take a look on the left-hand side here, we can look at the Databricks provides you with a catalog view right next to the side here. Okay, so you can go into the blob insight, and then there's the block volume that we created just now. Now, lastly, with the vector search, we need to upgrade the package that we have for Databricks, as currently I believe this is still a preview item that they don't have fully integrated into our library sets yet. Then at the end here, we're going to create our vector search client or the vector search endpoint compute that we have. So this endpoint basically will help us manage our indexes in a little bit. We'll be creating that in our kind of third step that we have here. And this usually takes about 5 minutes to run. So even though it's return telling you it has been created successfully, it will take some time to run as it's showing that it's still provisioning in the respawn here. So so yeah, and you can also create this manually through the user interface as well. And I can show you quickly how you go about doing that. So you can go into to do that. We'll navigate to the compute under vector search. So you can see this is the endpoint or the compute that we are provisioning right now through the um, through the API, but you can click on the create endpoint on the left there and provide a name. It's a very simple interface. There's not much to this because all the complexity of managing the vector will happen. The the configuration for the vector setup will all happen at the index level. So this is just a container that holds the compute and the to help us manage our factor indexes later on. Okay. So the next step that we have while we wait for this to be provisioned is let's go grab our data from the blog and then we will generate a clean data set, right? Because as you saw earlier, we only have a volume container. We don't have any delta table yet. So in that case, I provided a few links here in my notebook. So some of them talk about the links talk about how we download the file, how we did unzip the file in Databricks, and how do we going to parse the markdown file as well, which we'll talk about in a quick minute there. So for the sake of our demo, I'm not going to go retrieve um, the blog from my friend's Connor's website in GitHub, as there's a limit on how many times we can hit that kind of endpoint. But essentially here, you will create you will download the master.zip file, kind of like when you go to the GitHub repository and then you click on the download zip button, basically. We will retrieve this data and then we will essentially use the unzip command or the extract all command here to extract the files and you will save it up into our catalog here. So while I'm explaining this, just go click run all and we can step through the code through that. So we're gonna quickly take a look at the catalog. We'll take a look at the structure on how um, the GitHub.io essentially set up their blog, right? So this is my friend's um, repository, and then this is the master branch essentially, right? So this is how the different folders that they have. And what we really focus on and interested in is the post um, folder. This is where all of the articles that he creates, it's all placed in this post folder. So this is where our primary area of interest is, and we'll then take a look at some of the markdown file, what they look like as we reading them into the Databricks, and how are we going to extract and process them, right? So first, to do that, we need a few libraries. So the first library, to no surprise, is the Markdown library. So we can help understand what the Markdown file means. And then the next one is called Beautiful Soup 2. And this is a common library gets used to uh, parse data into a specific format. So we will be using that to um, convert the markdown structure and format into something more familiar with us, which is which is the HTML kind of nomenclature there. Just give us an easy way to understand what is a header versus what is a body of the post there. And then finally, there's something called a Python fonts matter. And what this library does is to extract the header information within the markdown file. So, which normally we won't be able to do easily otherwise without a whole bunch of regular expressions. Okay, so let's see if I can actually open the post in here. No, they won't let you open the post. So instead of doing that, um, what I did was I defined a bunch of variables for us to use, basically just telling me where the path of the file is. Like we talked about the post directory here, and what do we want the target table structure is. So since Databricks doesn't give us an easy way to open up a markdown file, what I did here is I just picked a file that I know it's in his data set, and I'm basically just taking a look what this file looks like, right? So we can show you guys what the content looks like. So what the spark.read.text does is read each of the file line by line. So it spits out, there's this triple dash format, which in font matters means this is the beginning. It wraps the beginning of the end of the headers. In um, in the of the markdown file, and then you have things like title, date, categories, and tags. Sorry, and those are all important information that we want to extract from the header information. And then the next thing is we have an image. So this is the just the image that he has on his s- on his kind of like a title image that he has in his blog. And in our case, this image isn't very useful. We're not planning to process that. I mean, in some cases we might want to, but in his blog, this is just a title image that he uses. And following that, we get the details of the blog. So the introduction, we have a kind of introduction text, and then various different texts that he a paragraph that he has to talk about in this case the AI safety objective there. Okay, now I only limited to 30 rows. Of course, his blog is much longer than that, but they just give you a sample of what the block structure looks like and how we would navigate and parse the data using the three library that we mentioned earlier. So the next step here is really to define what the markdown structure really has, right? Like what we talked about. So we have a user-defined function, like that we saw in the previous slide. That besides the table, the volume, there's also you can define your own custom function. So in this case, we're defining the custom function to match the metadata of the markdown file. So we have the title, date, category, and tags, like what we talked about earlier. And the categories and tags are multiple arrays of strings. Oh, they're a string arrays essentially. So we define what the dictionary for the metadata as well. So we saw the title, and then inside the title is the title itself, right? So we need to define all of the intricacy that it has for the markdown. And what this does is we're using the formatter and say whatever the markdown content is that the file content itself that we saw earlier, we're going to load it into the post variable, and then we're going to ask the metadata dictionary to extract the title, date, category, and tag, and we're going to return those value back. And then down here below in this function, we will then, sorry, just one sec. Apologies there. There's a little bit of a cold that I'm fighting off here. And then lastly, that we're parsing also the content. And in that case, we are, like we talked about, we want to convert our markdown structure into the HTML tag, and we're going to extract each of the paragraph or the headings out of the content as well. So I won't bore you too much with the detail of the regular expression, but basically we're ignoring the header, and then we're removing um, the image raw tag that we have, and then we're asking the markdown library to grab the data, and we're going to parse each of the elements out. Pretty much in here is just the code to extract the element itself out of the content and so forth. So the next step here, we are going to loop through this folder, and we're going to process each of the markdown file one by one here. So after that calculations, you can see this is my content. Yes, the header and then the details. Yes, the file path and then the file name. So those are all the initially to read off of the markdown file itself. Then the next step here, we will actually execute those or call those user-defined functions, and then you will process all of the data and extract them based on our design functions above here. An important thing to note is in order for our vector search to work, our delta table or the data frame has to have the enable change data feed enabled. So that's an important aspect that you will need to ensure that your table has enabled. And then since we have all of this data processed, we're going to save it into the table name. So now if we navigate back to the catalog here on the left, we need to refresh our catalog as the things have changed. We see a table created, which is the blog stress. And we can also select that table and see what that looks like. So this table has quite a bit of records. So I'm just going to focus on the the block with the title of AI safety that we saw earlier. So as you can see, this created 785 records, and we can have different categories, different tags, has all been parsed out into individual columns. And we can see, earlier that the introduction is a header, it's a H2 header, and then we have various different paragraphs that we parse out of the markdown file. Okay. So that basically process our data. This is essentially our clean data set at this point, the block shares table. Then the next step we're going to do is we will the next step we'll do is now we can start utilizing our vector search, right? Now we have the clean data. The next step is to produce your vectors and saving it into the vector database. So again, I'm just going to execute the run all command. This will again upgrade our Databricks vector search library. So if you're doing this at home on your own time, make sure that your vector search has been created successfully. So under compute, again, back to the vector search, make sure this is at the ready states before you run, okay? But since we have been going through the ingestions and processing notebook, everything should be ready to go. So as they're upgrading, we're going to skip ahead and start talking at each of the step we have. So we're defining the we're going to grab the endpoints that we saw earlier. So again, this is the name that we said earlier, right? The vector search blog insight. This is the endpoint name or the vector search name, the compute name that we use. And then the data, it belongs to the catalog of BU ops in here under the schema project blog insight. And we're going to use the Databricks embedding model called Databricks BGE large yen there. And then we need to also provide the final table name that we compile. Again, we're using the three-level namespace, which is the catalog, schema, and table. So in the case, this is the BU ops. We have the schema as the block insight, and then the table of blocks. And then we also be creating the index. So this is the index that's being exposed by the vector database itself. Right. So with our vector search endpoint created successfully, as you saw earlier, it's ready to go. What this block of code does is it retrieves the endpoint using the vector search client. So this is a library that Databricks provides. You just have to import it from the library there after you upgrade the library from above. And it tells you that now your status is online, where previously it was provisioning. Then now you can go ahead and create the delta sync index like we saw in the diagram previously. And in our case, we want to create the pipeline type as trigger instead of continuous. And the reason why we're doing that for the demo and probably most of your use cases is the trigger pipeline type or the mode that you're using will allow more efficient use of your cost management perspective. If you have a lot of data coming in all the time, then continuous mode it will make sense, but you are keeping the compute running 24/7 in that case. Where the trigger mode, you will only run it when you ask it to run. Then the next parameter here is the primary key. So we generated for each row, we generated an ID for that row itself. So row ID is used on that. And the column that we want to embed is the content column that we saw earlier. So just provide that. And then we also provided the endpoint or the compute that we saw and defined earlier. And then finally, I also configured the sync compute embedding to be true. And what this parameter does is it creates the table that contains the embedding vector, so that if we want to back up that table ourselves, we could do that in the case of if we want to create a backup copy of that data, or you want to build other process around that with that data set. So this step usually takes a few other minutes to run. Now, what as they're now going through each of the rows inside inside our Delta table, and then they're creating this pushing it into the vector DB after we embedded them, and then exposing it as an index for us. So as you can see in the even though both of them are under table, you can see the icon is a little bit different between the two. There's a little index kind of shape that's on the table itself, and when you put your mouse over it, it will tell you that it's an index. So at this moment, while we're waiting for it to run, I want to navigate us back to the catalog so we can take a look at the difference between the table versus the index itself. And we can also keep an eye on the status of the index. So this is our original table that we saw earlier that you saw us create. It wasn't created too long ago. And we can even take a look at the sample data if we start up the the warehouse serverless compute. While we wait for that to start, oh, there we go. That should start pretty quickly. We can see all of that category that we mentioned earlier. Um, my friend talked about different things, CI/CD, Azure, containers, many different things here. So in here, we can see the change data feed is enabled under detail, which is an important aspect that we talked about earlier. Okay, there's not much detail here. So if you don't want to create the index through the code, you can also create an index through the UI here as well. So you can go to create vector search index and basically pass in the exact same parameter that we did earlier, right? We select the primary key, which is the row ID, the endpoint, which is the inside endpoint, what columns do we want to sync, right? I think we selected the content in this case. And then we want Databricks to create the embedding for us, right? Now, if your table have already embedding created, you can also select the use existing embedding column. Of course, when you select that, you need to have a column that have the same the proper type for the embedding. But for our case, we go to compute the embedding. So the source column is again content, and then the embedding model, like we talked about, was the GTE large there. So the one question you might have is like, what kind of model does Databricks have available, right? So under the machine learning serving, you can see all of the serving endpoints that they have made available. As we talked about earlier, you can configure your OpenAI GPT model. You got to put in your API key and so forth. But just out of the box, you have a Llama model here. You have the BGE embedding model as well. Okay. Now, I believe I did see the index being created and as well the write back table, which means we probably finished processing all of our data in our data table. So we can see this vector index now is active. Um, we can see the table is what it's from and what endpoint is it using exactly, and all the rows that have been processed. So it has 1,000. 224 rows that got processed. It ran pretty quickly, I think, here. So if we look at the column of this index, we can see there's the Databricks contents vector here, along with all of the other columns that we want to bring into the vector search in case we want to do filtering. So again, we can look at it through a sample data. And if we scroll to the right, we should be able to see the vector array itself. Now, we can definitely look at the write back table. It's going to look exactly the same as your index, but this is actually a delta table itself, where previously this is a vector index. Okay, just make notes of that. If you guys want to back up this table, you guys can copy the table um, if you want to. Now, with all of that loaded and ran, we go back into our source code here, our vector search code, and let's take a look here. Some of the failure happened because we were still waiting for the index to be built completely. So now we can see that our write back table is working as we saw earlier, and we can now do some similarity search, right? As we talked about, this is the 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 retrieval of the top 5 results or whatever not. So in my case, I'm saying, do we have any articles on LLM memories? And the column that I'm interested in is the row ID, title, and content, and I want the top 10 results to come back. So in here, they return back the 3 columns that I specify: row ID, title, and content. and then they also give you the similarity score that you returns back. Obviously, the higher the number, the better. So in this case, if we look at the top five results, they are all on the topic of strategy for managing LLM memories. How do we deal with how does LLM remember what you asked previously, and as well as how they manage when your message starting to get long, essentially. But there's other things that talks about for chunking of the reg as well. So there's a lot of different topics that we can that meet the criteria of LLM memories that we asked. And we can continue to asking different questions. Again, this is similarity search, so our query text is very straightforward and simple. We're not, passing in a lot of context of the data. That normally will be all done through the um, the prompt engineering side of things to build the query text to be a lot more complicated than what we have here. This is just an examples on how we can use this uh, use a similarity search that's provided by the index. Okay, so yeah, so again, this asking on the reg and how to chunk data. Again, we talked about that a second ago. Chunking for reg is the kind of the primary answer that comes back. So if you're going to return the first top five results, it'll be all about chunking for reg article, and we want to use the completion chat to compile the first top five results and spit it out into or return as a human kind of response back to the user. So with that, that pretty much runs through the vector search option here. So with that, I'm just going to quickly run the cleanup scripts so we can clean up the resource that we have available. Okay, so with that, we'll jump back to the slides. So we cover the markdown file here, how we generate our clean delta table using the index to store all the data into the vector database, as well as creating our own embedding table out of the through the index provided. We also saw that we could use the index to um, answer users' query and return the top five results in or top 10 results in our case from the vector database. So with that, we'll move to our first Q&A session here. The first question I see on the chat here talks about Azure integrations with other Azure services. What are some of the optimizations best practices for large data processing and workflow? So I think it depends on the service that you're using. Quite often for large files, especially talking about media files, um, the best practice there is upload them into a blob first. You might do that like what we talked about earlier using something like an Azure Data Factory. You might want to start that process there, um, having them kind of chunked and processed from that, or not so much chunking, but having them processed from that perspective. And once they're ready, use Databricks to query it. As for example, Data Factory can have a direct integration with Databricks. If you want, you can also build that all into your Databricks using notebook and APIs, as Databricks has the capability of building pipeline workflows that can execute that on a schedule run basis. But in that case, you will have to um, still upload the data into the Azure services as well around that. For smaller data, depends if you need to use, there's like PDF libraries that you can use if you want to extract text from that. Um, or if you want to use the Azure library, you can definitely call the APIs directly from that perspective. Okay. Hopefully that answers your question. Any other questions before we continue to the uh, next part there? Okay, we'll jump right back into our slides. Just really two quick more slides here around the Databricks Genie. So Databricks created an AI BI Genie, and what this Genie does is basically AI assistance that's powered by OpenAI, and this allows you to talk to your data using the natural languages. The Genie can translate your queries or inquiries from natural languages into SQL, and retrieve any relevant insights based on your data sets. Additionally, you can create basic visualizations like charts and graph. Of course, be mindful about the Genie. The Genie is primarily for you to interact with your data. It doesn't have the chart completion or summarizations capability that you would have if you're building a custom AI bot, of course. So a quick demo around that is we have some small data sets around customer, and the invoices that we send to the customer, and different lines of purchases that the customer is being invoiced for. So we're going to do a very short and quick demo around that. So jumping back into the Databricks environment, there's a Genie tab under the SQL environment. So the Genie is primarily being used for business users as well as data analysts as kind of the primary audience of this tool. Of course, anyone else can use this as well. It just very naturally fit to those user base here. So I will name my Genie the sample sales data Genie, and we're gonna copy and paste a quick description here, telling describing what our what our Genie does, right? So we're gonna interact with three different data sets: the invoices, invoice lines, and our customer data. And then we can ask, anything regarding the invoices, revenue, profits, and things like that from our Genie. This is going to run in our standard starter warehouse. So this is something that built into Databricks. There's a starter warehouse. If you're admin or Databricks instance, you can set up additional warehouses if you desire to do so. This is just a small, I think a 4 DBU warehouse that it comes with the Databricks. So for the table, we want to navigate to a different location this time. I saved all of those data into the demo catalog. So we go to Sample Genie, and we can click all of this three tables here and click Confirm. Now, based on the description we provide, there's some sample questions that we can ask. You don't have to add this. This is optional. I think for me, it's just a good best practice there to add them to help your user to know that what kind of questions they can answer. They can ask the data set. And with that, we'll just quickly click Save, and then we'll jump right into the sales data Genie right away here. So we'll ask maybe some basic questions like, what can you tell me about the customer data? And it's a very basic, simple questions here. So they talk about the customer data table, has the customer and what columns it has in the data set. And it helps with demographics, communication channels, etc. So maybe let's ask something more intricate, right? This is a single table question. For sure, we hope that Genie can definitely easily do that. Now, how about we want a specific data from revenue generation from February of 2024, right? So this data set contains about 4 months of data, the first 4 months of 2024, and we'll see what we get back here. So this includes two different tables. It tells you the invoice and the invoice line. The invoice line contain all of the financial information. So it makes sense that we are consolidating or joining the two tables, where the invoice actually has has a date information. So in addition to this value, they also provided the code, the SQL code that gets generated with this data set here. So here it says that our invoice date has to be bigger than or equal to February 1st, and it has to be less than March the 1st. So this is good because February could end on the 28th, on the 29th. So this query looks very promising for what we need. And if you want to utilize something similar to that for BI purposes, you can also retrieve the query there. So let's see what the next thing we can do is. So we got the total revenue, but we don't really know which customer is our that generated the most revenue, has made the most purchase here. So maybe let's try to ask that, right? We'll expand our questions a little bit, and now we want them to not only look at the invoice pricing information, the date, but also retrieve the customer that are spending the most money here. Well, this is great that they return the customer name and who the contact person was, but we really have no idea how much they spend, which isn't ideal and or useful at all. So let's add that into our query. Ask them, so how much did this customer spend? Give it a few seconds here for it to process. Okay, so now they have modified the return value or the response and tell us that they have spent a little over $65,000 there. Um, Maybe perhaps I want to see how much they spent for each month from that perspective. So you can check that. Let's take another second here to return again. Looks looking pretty good. So for month one, this is really returning. Although this is correct, not the ideal format I want them in, but this table is looking really weird. Although they do have the proper dollar amount value there, so I really want them to report the data in year-month format. So we'll ask them to go ahead and do that and see if we get a better results coming back, right? Think of this from a user or like a business user perspective. They may want to generate this diagram for the report to the executive or rolling this up to the branch manager, for example. So being able to ask your data to change the format is very important here. Now, this isn't great either, but maybe we can edit the visualization, see if we can do something a little bit better. Let's try a bar chart, what that would looks like. That still looks kind of funny there. See if there's a way we can tweak this chart a little bit better here. Okay, it looks like it's not really doing what I wanted to do, which it can happen when you're doing things with Gen AI, right? Like I wanted really to show the chart where we only have three different columns instead of three different bars at the bottom instead of having this kind of funny business there. So let's see if we can. Oh, actually, interesting how that switch make that happen. But in any case, now we can see that the um, this customer has made most of the purchase in March, followed by January and February as the last one here. Now, this is all sounds great. How about, can they really return? This is all directly with our data, right? They just kind of running a query essentially and putting it into a sentence. If this tool is so can do so much, is there a reason for us to build even the reg tool, right? Essentially, and one of the most powerful things in a chatbot, which is a similar UI that they have here, is you can summarize the results through completions. So can they actually summarize this response? No, they're not able to draw any conclusion from the result set. So it's important to note that the limitations of the Genie is primarily to query the data and return to generate the SQL for you to for quick analysis or data discovery purposes. Okay, it's not meant for having a full chat functionality that you would have, for example, in your own custom built chatbot there. All right. So that was kind of the demo there. We'll jump to a second Q&A sessions before we do the summaries. Any questions the team has? Got a question on the chat here. Ashraf, what do you mean by Databricks different here? Can you elaborate the question a bit? Compared to other searches like OpenAI. So actually the Genie uses OpenAI as the backdrop of the response. Yeah, so it depends on how you want to utilize the yeah, so from that aspect is it's pre-built out of the box, so you don't have to configure all of the OpenAI, you don't have to build any of the integration. You're able to generate the SQL quite well, and you can also take the SQL into your BI. So in that prospect, it's pretty similar to the OpenAI chat interface there. Um, but I think the main benefit of Databricks is it's a single tool, right? I know OpenAI also offer like things like vector databases in the first portion of our demo. So it's similar that different platform or different services are starting to build an integrated product that you can use without having to jump around to different tools and connect to different APIs to retrieve those data. In terms of performance, the Unity catalog works pretty well. A lot of big company uses the Unity catalog or the Delta Lake format for their data workload, especially, and it's much more compressed and easy to use compared to, let's say, a CSV files that you will maintain on a regular basis. Um, the price to cost the data usage ratio in terms of querying, it's also relatively well priced. Of course, you're getting the full platform, so there's a premium to paying that service in order for you to able to have both the data and the AI team and the business team all working under one product there. Okay. Yeah, so the pricing varies, depends on how much the product you use. In Databricks, everything is charged by DBUs. I believe the last set of number I saw for the factor databases, the index that we ran, for example, it costs about 35 cents USD per DBUs. So I think my whole demo might have only cost a few bucks to run completely. Genie, they run on the SQL Server, a SQL warehouse instance that they have built in here. It's the SQL warehouse starter here. So um, this is also not like a few bucks an hour, if I remember correctly. So you can also use this to connect to your Power BI, Tableau, and other BI services as well if you need to. So not that it's quite economical, this solution. I think yeah, when I developed this whole solution in my demo, um, I think it costs like 30, 40 bucks, and that's with me keeping servers running while I'm trying to figure out some of the code as well. So yeah, it's quite reasonable to keep it running. Um, are you streaming data for terabytes in terms of is in terms of like for Gen AI or for data processing? Because not sure you want to throw quite terabytes of data into into a Gen AI model, but for data processing, um, there's a few ways to do that. You can go through a batch processing. Another way is going through um, micro batching or streaming. I think I did sessions here a while ago with this audience for both solutions. Maybe I recommend you look back to the Dear Azure channel and go look at the Databricks presentation that I've done with this with a user group here. I do have to warn you, the code has changed slightly since then. Because of Unity Catalog, there's some minute differences in the code, but by and large, the structure of the code is still quite intact. I'm sure the event manager here can share the link there with you. So there's no more questions. We'll wrap it up right here with a quick summary here. So what we learned today is we focus quite a bit of our time on the Mosaic AI Vector Search that Databricks or the Azure Databricks provides. We started with a delta table. Well, actually, we started with volumes, and then we created our clean data set in a delta table. This is where the journey onto the vector search kind of begin. We created the delta sync index. In this case, we want Databricks to create the embedding for us using the delta table. And yeah, and so we are expecting Databricks to kind of manage and keep up with the changes through the through the use of the index and the vector search endpoint. We quickly cover some components of the Unity catalog. We didn't go very much in depth due to the contents that we have on the Mosaic Vector Search, but we covered the key item there about the three-level hierarchy with the catalog, the schema slash database, and the tables volume, as well as we also saw the user-defined functions in action today. And lastly, we quickly touch on the AI BI Genie. It's a powerful assistance for us to query our data using natural language, able to do sum and joins quite nicely, but it has its limitations as well. So just be aware of that. Databricks is expanding the capability of Genie so that it can be used within their dashboard as well. But that's a preview item that's just released recently. So finally, the code for the repository. So here's a link for the code here. The code covers the Mosaic Vector Search and all of the Unity catalog components. Unfortunately, Genie is not something we can codify or convert into code. So I provided the data set in my repository, but there will be no code included in that case, as we have to set that up through the UI manually there. And finally, if you want to connect with me, here's the link to my LinkedIn. Yeah, thank you very much for you guys' time and for the user group to hosting me today. Hey, Kazim, are you back?
Yes, Wilson.
Perfect. I think that wraps it up. If the audience have any questions or the user group member has any questions, yeah, feel free, they can